Good day, my fellow listeners. I'm William Abraham, sometimes known as Kwakbole William or I'm Abraham. By the grace of God, I'm here today to do a video on binary operation, a short clip on binary word operation. Today being on the 1st of October 2024. So I would like us to look at just look at it, or when you like it, you click on the button. You try to subscribe to it. Now, and when you do that, God will richly bless you. Now, let's look at this plan. Today, I'll be dealing on binary operation, mathematics class, binary operation. I want to be looking at this topic, binary word operation. Now, what do we mean? What is an operation? Before now, we already know that mathematics is made up of four major operations. When we talk about addition, subtraction, multiplication, and division. These are the four major word operations that make up what? Mathematics. So here, if we are looking at it in this realm of mathematics, we want to use it as binary operation. What is binary operation? Binary operation is simply a calculation that involves two elements of the same set to produce another element of the set. I come again. I say binary operation is simply a calculation that involves two elements of the same set to produce another element of the set. Now look at this. Now, if you are given a set, for instance, we are given a set S, and a set that set S is a set of even numbers, positive even numbers. Let's assume positive even numbers. For example, we have 2, we have 4, we have 6, and so on. If we have this as a set of positive even numbers. Now, if you look at this set very well, as it is now, how do we go about it? We have addition, we have multiplication, we have subtraction, we have division. Now, if I want to define binary operation now, let me show you something. Now, how do we define it here now? Listen. In this place, for we to define this set, we define this set under a given word operation. What is the operation? Let's use addition. Now, if you look at it very well, under addition, we say 2 plus 4 is what? 6. If you look very well, 6 is a member of the set S. This is the set. This is the set now. Remember, this symbol you are seeing now is a symbol for what? Membership. Why this one is a figure for what? Not what? Membership. Membership, not member. Now look at it. 6 is a member of this set. 6 is an even number. This one is positive even number. If we come here and say 4 plus 6, it points us to what? 8, which is 12. Sorry. 10. That is a member of what? The set. 8 plus 4 is 12. It's a member of what? The set S. So if you look at it, 2 plus 4 is giving us 6. So like when I define binary operation, I make you to know that binary operation is a calculation that involves two elements of the same set to produce another element of the set. So what we have done, you can see that in the operation here, you can see that these two elements could produce this from what we are seeing here. 4 plus 6, which is this 4 and 6, could produce 10. It's a member of the set. 10 is a positive. This 10 here is a positive word, even number. Now we say 8. 8 is a member of the set, it's an even number set, or positive even number. 8 is an even number. Plus 4, another even number. Give you 12, an even number. Under the word, they say. If we come to multiplication, the same thing. We can say 2 times 4. It will give us the same as what? 8. They are all even number. 8 is a member of the set. You see, when I say 4 times 6, will give us 24. It's a member of the set. It's an even number. You see, we can say that 2 times 6 is 12. A set of what? Even number. You can see now it's a member of the what? The set. So you can say that it's a member of the what? The set S. So this is what we are talking about. So when we say define binary operation, I said that binary operation is simply a calculation that involves 2 elements. Look at it now. Of the same set to produce another element of the set. We have tried it in addition and what? Multiplication. So I want you to get it. That is it. But now, in another aspect I want us to look at is to define, how do we define binary operation? You see, we say defining binary operation. We want to define a binary operation. What is the operation defining? The operation is defining a given word set. So any operation, the process of an operation defining a given set, and if you define it very correctly, we call it definition of what? Binary word operation. Now look at this statement. Let me show you something. For example, you are given an example here. Let me give you an example here. Example 1. It says an operation, asterisk, is defined by what? A asterisk B as A plus B over 4. We can now say find 2 asterisk 4. We can talk about this. 2 asterisk 4. We can talk about find this now. Let's look at this now. You see, if an operation asterisk is defined by this, find this. If this is given to you, all you just need to do to define this operation is defined by this. This is what the law of this operation is saying. Look at the law. So all we need to do is to obey this law by defining this. So meaning that in this case, solution, you find out that your A is 4. Look at it. We have A asterisk what? B is equal to A plus B over 4. That is to say, in this operation, if we have 2 asterisk 4, our A is 2, our B is what? 4. So we write it, we say 2 plus 4 divided by 4. And that will now be 6 over 4. So therefore, 2 asterisk 4 can now be what? 3 over 2. We just define it. Now, let's look at this example too. The operation asterisk, take note of this. Any symbol can be used in place as an operation. There are many other operations, not just asterisk. Symbol like this can be used. Symbol like this can be used. Symbol like this can be used. Symbol like this. Symbol like this can be used. Any symbol can be used as what? An operation. So I just want you to understand that. So when they say a given operation. Now, in a case like this, the operation asterisk is defined by this. Find the value of 1 asterisk 3, 2 asterisk bracket 1 asterisk 3 asterisk bracket 1 asterisk 5 bracket close. Now number 4, you now said if s asterisk 2 is equal to what? Say find the value of x. How do we go about this? Look at this. Like question number 1 here, Roman figure 1. From the law here, the law states that, which is the binary operation now, we say that it's A asterisk B. Defining what? By what? As this. We define it as this. So whenever you see anything in this manner, you define it as this. That's what we are saying now. Now, for this set to be defined, what we do, like question number 1 here, Roman figure 1, we said it's 1 asterisk 3. So in this case, our 1 is taking the place of A. Our 3 is taking the place of B. So we cannot define this as 1 plus 3 over this minus 1. If you look at it now, we are defining this now just as it is here. So what we do now, we say over what? 2 minus 1. This divided by this, it become 2 minus 1, which is what? 1. That is for Roman figure what? 1, which is this. Now, normal figure 2, what we do is we talk about this by saying 2 asterisk 1 asterisk 3. We talk about it like this. But here we are going to apply the law of Bodmans. What is it by Bodmans? Look at me. We start from bracket. Are you getting me? We must finish with the bracket. And when we are dealing with this bracket, we make this one constant. Just follow me. Look at it. Now, what we do is we say 2 asterisk bracket. Let's start with this now. 1 asterisk 3. Remember the law. Our A here is 1. Our B is what? 3. So we go and say 1 plus 3 over 2 minus 1. Which is what? 2 asterisk. Look at it. 1 plus 3, 4. Divide by 2. 1 plus 3 is 4. Divide by 2, it becomes 2 minus 1, which is 1. Look at me. This plus this is 4. Divided by 2, it becomes what? 2. Minus this one is 1. You see now? So from here now, I can easily clean this off and start afresh again to use this 2 asterisk 1 to obey this law. Obey this law meaning A becomes 2, our B becomes 1. We can say 2 plus 1 over what? 2 minus 1. Meaning that 2 plus 1 is 3 over what? 2 minus 1. Which finally we can say LCM. 2 and 1, assume this over 1. 2 and 1, we can take the LCM as 2. 2 into 2 is what? 1 times 3 is 3 minus 1 into 2 is 2 times 1 becomes 2, which is 1 over what? 2. So meaning that this statement here, 2 asterisk bracket 1 asterisk 3 bracket close, is equivalent to this, equal to this 1 over 2. Now let's look at question number 3 here. In number 3 here, we have it as this. We now have number 3. We said it's 3 asterisk bracket 1 asterisk 5. We have it like this. The same thing. Now we pen 3 remain pending. We start with the bracket 1 plus 5 over 2 minus 1. Just as we have done before. The same thing. 3. 1 plus 5. 6 divided 3. It becomes asterisk 2 minus 3. 1 plus 5. 6. Divide by 2. 3 minus 1. Meaning here become 3 asterisk what? 2. We continue again by the same law. We say here become 3 plus 2 over 2. Why? Because look at 3 asterisk 2. Our A is taking the 3 is taking the place of what? A. 2 is taking the place of what? B. Look at it. So what we do now, we go on now by minus 1. So here become 5 over 2 minus 1. So finally LCM 2 can do this. 2. We say 2 into 2, 1 times 5, 5, it is over 1. 1 into 2, 2 times this is minus 2. So finally here we have it as what? As 3 over 2. Which is this number what? 3. Which is this number 3 now. Now from here we want to look at this number what? Number 4. You see if S asterisk 2 is equal to 4, find the value of X. Now we are saying that X asterisk 2 is 4. But we know what the law is saying. This is an equation. The law is telling us A asterisk B is this. Look at what we said. So for we to obey this, being an equation, we said that here become S is now A. 2 become B. We now say X plus 2 over 2 minus 1 is equal to 4. So what we have done, we just define this now. To define this here become this. Equals to 4. So you multiply both sides now by what? 2. Use this 2 to multiply everything. So if I use this 2 times S plus 2 over 2 minus 1 times 2 equals to 2 times 4. I multiply everything by this LCM. These 2 now. So these 2 can cancel this. It will be left with S plus 2 minus this now become minus 2 equals to 8. So 2 minus 2 have cancelled. So S here become what? 8. That is all. So now, when next we meet, we are going to continue with the video. We'll be talking about closure what? Property. God bless you as you subscribe to this channel. God bless you.